Now, a line has its NDA 10 mm above HP and 15 mm in front of VP, and the NB is 55 mm above HP, and the line is inclined at 30 degrees to HP. The distance between the end projectors is 50 mm. Draw the projections of the line. Determine the true length and its inclination with VP. So NDA is 10 mm above HP. So when you look from the front view, we can see the distance NDA, which is above HP by 10 mm. When it is projected, that image will going to fall on the vertical plane. You will going to get this point as small a dash, wherein it is distance above HP by 10 mm. And 15 mm in front of VP. So when you look from the top view, we can see the distance in front of VP is this distance. When it is projected, it will project onto the horizontal plane. So this point will be top view small a. So then the NB is 55 mm above HP. So when you look from the front view, we can see the distance above HP by 55 mm and draw a horizontal dash dot line. So this will going to be the locus of B in the front view. But now the line is inclined at 30 degrees to HP. So now since the line is given is the true inclination of the line. So with the end A as center, with A dash as center, by using the protractor we measure an angle of 30 degrees and draw an inclined line so that it will going to cut the locus of B at this point. So we will going to get small b1 dash, and which will be the true length line. Since it is the true length line, you will going to get the small a and small b1. So we know that this is the true length in the vertical plane. So obviously that line will be parallel to VP. You can see that NDA is here and B1 is here. So that line is parallel to VP. So you are getting this line. And the line is inclined. So we will going to get the true length. And the distance between the end projectors is 50 mm. So since the distance between the end projectors is 50 mm, now here from here you measure 50 mm. From the end projector of A in the vertical plane you measure 50 mm and draw a vertical projector so that it will going to cut the locus of B in the front view, which will be B dash. Then join A dash B dash with a dark line here. So we are going to get this. Now in the top view also we can measure the distance of 50 mm and draw a vertical projector here. So we will not be getting the locus here. That is basically because we have the true inclination with respect to HP, and also the distance above HP is known, and then the distance between the end projectors is known. So we have the distance between the end projectors in the front view and also in the top view will going to be the same, and that means it will be on the same line. So that means we have the top view line of the end B must lie on this line. To get the top view line, what we should do is we should have the front view line of the true length. So which is the front view line of the true length? The front view line of the true length is A dash B1 dash. So we know that this is the true length in VP. So that means that line has to be parallel to VP. So here NDA is in front of VP by 15 mm. So that B1 should also be in front of VP by 15 mm. That is what we have got this line AB1, which is the true length line. That is basically because this is parallel to VP. So when it is projected, you will going to get this small AB1, which is parallel to VP. That means you are projecting from here also, so that you will going to get this top view line, which is AB1, which is in front of VP by 15 mm. But actually the top view of the end B must lie on this end projector, because we have the distance between the end projector distance is given to be 50 mm. So with A as center, you take the radius of AB1 and then draw an arc such that it will going to cut the end projector line at this point, and you mark this point as small b. Then join A to B with a dark line. So in the sense that, so when you are doing so, what happens when you look from the top view, since we are rotating the line which is capital AB1 in space, when it is rotated such that the B will going to lie, the projector endpoint of the B must lie on this particular end projector, which will going to be this point, so that you will going to get this point B. Then join A to B with a dark line. So since we got the point B in the top view, so you are going to get the locus of B in the top view, which will going to be this, and you write locus of B. But now we got the top view and we know the true length in the front view. Now we need to find out the true length in the top view. So how to find out the true length in the top view? You make the line, the front view line is to be made parallel. So how to make that front view line parallel? So with A dash as center, you take the radius of A dash B dash and you draw an arc such that A dash is above HP by 10 mm. So B2 dash is also above HP by 10 mm. And then draw a vertical projector in vertical plane and then draw a vertical projector in the horizontal plane, so that both these will going to cut the locus of B in the top view at this point. You mark that point as B2, then join A to B2 with a little bit darker than the projector line, so that you will going to get this as the true length. But when you are doing it in space, how to do that? With A as center, since you have the space line AB, then with A as center, you take the radius of AB and rotate the point B such that A is above HP by 10 mm and B2 is also, capital B2 is also above HP by 10 mm, so that you will going to get this line AB2, which is parallel to HP. When it is projected, you will going to get it in the true length in HP. Now, while doing so, what happens? The image will going to be rotated from B dash to B2 dash, that is A dash is above HP by 10 mm, B2 dash is also above HP by 10 mm. So from there you draw a vertical projector and project this to this, you will going to get the top view point of B2. So this is how we can analyze in 3 dimension. And when you are transferring this into the orthographic view of the 2-dimensional plane, that is by using the sketchbook. So first we will go to draw the XY line and mark VP and HP. And first you draw, you take the distance above HP, which is 10 mm. Above XY line you measure by using the scale 10 mm and you mark the horizontal line. And similarly 15 mm in front of VP. From XY line you measure the distance of in front of VP, which is 15 mm. And it will be on the horizontal plane, since the horizontal plane is below XY line. And you draw the 15 mm horizontal in front of below XY line, and you measure 15 mm and draw a horizontal line. And consider any point and draw a vertical projector, so that it will going to cut these 2 horizontal lines in the front view as well as in the top view. And you mark this point as A dash and A. Now, the distance above HP is given to be, NB is the distance above HP is given to be 15 mm. So from XY line you measure 15 mm and draw a horizontal dash dot line and you mark this point as locus of B. You mark this point as locus of B. So then, and the line is inclined at 30 degrees to HP, so we know that since it is the true inclination of the line, so with A dash as center, by using the protractor you measure an angle of 30 degree and draw an inclined line such that this line will going to cut the locus of B at this point. You are going to mark this point as B1 dash. So this will be capital B and this will be capital A. Because the line is inclined at 30 degrees, that means you have the true inclination of the line. So you got the true length. So the length of this true length will going to be the 90 mm. Now, and we also know that, so once we get this and we have the distance between the end projectors is 50 mm. So with A dash we have the projector A. From projector A you measure the distance of 50 mm horizontally and then draw a vertical projector so that it will going to cut the locus of B in the front view at this point. So we got the front view line, and we will going to get the front view line, which is A dash B dash. So join A dash B dash with a dark line. But now we have the true length in the front view and we have the front view line, but now we don't have anything here. So we need to find out the locus. To find out the locus, there are 2 ways in which you can do it. One is you rotate this A dash B dash, make it parallel to HP, and then you project this, and then since we have found out the true length here, you measure the true length and cut an arc on this, you are going to get the locus of B in the top view. And then we know, so since we know the distance between the end projectors you draw, you are going to get this. This is one way. But the other way is, So we know this is the true length in VP. Since the true length in VP, you have to make the line parallel to VP. So how to make that line parallel to VP? NDA is 15 mm in front of VP. So B1 should also be in front of VP by 15 mm. So you draw a vertical projector from B1 dash such that it will going to touches this line, so that AB1 will be parallel to VP. Since the AB1 is parallel to VP, so you are getting the true length in VP, which is already there. So now we have an end projector point from here, distance between the end projector point which is cutting this locus here. But since we don't have the locus, it will be extended till downwards on the top view. With A as center, take the radius of AB1, because since this is the front view, on this line only you will going to get the top view. But we have the top view AB1 which is here, the B1 which is here should come and touches this end projector here. So to do that, with A as center, take the radius of AB1 and draw an arc such that it will going to cuts this end projector at this point which is B. Join A to B with a dark line. So you are going to get this top view, and then you will going to get the locus of B in the top view. So this will going to be the locus of B. Now we know to find out the true length in HP. So to find out the true length in HP, you make the line parallel to HP. Which is the line which you make the parallel to HP? The line which is inclined to HP. The line which is inclined to HP is A dash B dash. With A dash as center, you take the radius of A dash B dash and draw an arc such that B2 dash is also above HP by 10 mm. So now A dash B2 dash will going to be parallel to HP. So we are going to get the true length in HP. So naturally from B2 dash you project this line to the locus of B which you are already obtained, so that you will going to cut this point here. So this B2 will be mark this point as B2. Then since this is parallel to HP, so you are getting the true length here. Join A and B2 with a little bit darker than the projector line. So since this line is parallel to HP, so you are getting this true length. So you mark this as capital A and capital B. Find out the true length and inclination with respect to VP. So by using the scale, you measure the distance of this, which will be 90 mm. And when you are doing it in CAD and manual. Similarly, by using the protractor, you measure the true inclination with respect to VP here, and you denote this by angle phi. Then phi will be equal to 41.63 in CAD. When you are doing it in manual, it will be 42 degrees. So this is how we will be able to draw the solution in the sketchbook. Now the same thing will be done by the step by step. So how? First you take above HP and in front of VP and draw these two lines. Then we have above HP by 55 mm. Draw this. You will go to get the locus of B. Then you draw the true length line, which is since we know the true inclination line, you measure true inclination line and draw this line which is going to cut at this point. So you are going to get B1 dash. And we know the distance between the end projectors here, which is cutting the locus of B here. So naturally we are going to get this line. But now we don't have the locus here, but we have the front view true length. So you make this line. So since if it is to be front view true length, the top view should be parallel. So NDA is in front of VP by 15 mm and the B1 should also be in front of VP by 15 mm. So this will going to become the top view. With A as center, take the radius of AB1. By using the compass, you draw an arc such that it will going to cut this end projector at this point. You are going to get top view AB and you drew the locus. So this will going to be the locus of B in the top view. So this will going to be the true length. So that is what we have done here. Since this line is parallel to VP, now we don't know this locus here, but we know this end projector which is coming on this. So this is the true length in VP. So now this is when you project this, you are going to get the top view here. And what you are doing is you are rotating this AB1 in space with A as center, B1 as the AB1 as the radius. You rotate it and make it such that this point B will going to lie on the end projector of this line, so that the image will going to fall on this. So once you get this point, so then you are drawing the locus of B here. So obviously when you look from the top view, you are going to get AB here, which will be in a dark line. So this is how we can do it in space. Similarly, when you are doing it in the front view, so we know the distance between the end projectors. So we have we know the locus also. So n projector is cutting at this point, so you know the B dash. Then you make this line parallel to HP. So when you make that line parallel to HP, because of the locus here, so you are going to project this, you are going to get the true length in VP. So that is the inclination which is phi, which has been measured. So when you are doing it in, since you are rotating like this, so that means we are rotating from capital A to B with A as center. Take the radius of AB and draw an arc such that A is above HP by 10 mm and B2 is also above HP by 10 mm. So that now it becomes parallel to HP. So when it is projected, so this is the way which is going to be rotated in space. In space, and when it is projected here, it will going to get the image here. So we are getting projection here, and since we are projected from this point, so we are projecting that also here. So directly it will going to come and make this point here. So this will going to be the true length in the vertical plane. So this is how we do the analysis for the second step, which is obtaining the true length in the top view. So this is the true inclination with respect to VP here. So this is how we will be able to analyze this problem. Thank you.